of powers of its prime factors. Don't get confused with this whole question. It says express 990 as a product of powers of its prime factors. Look, what I'm going to do is I will write here 990. I will do the factor tree method here. So what I will do, I will write 990 here. Let me fix this first. Okay. 990. I will use this method. 2 times 4 makes 8. This is 9. I cancelled it. What happened? I said 2 times 4 makes 8. So now I will take 8 from it. What I am left with? 1. I will put that 1 with this number. This becomes 19. Please don't say this is 10. This is 19. 2 times what makes 19? Nothing. 2 times 9 makes 18 actually. Okay, 18. I cancel this one, but I put the remaining one from this part here. This becomes what? 10. 2 times 5 makes 10. I did the grid prime factorization, but I use division actually. 2 times 4 makes 8, 2 times 9 makes 18, 2 times 5 makes 10. Now, as per my rules of divisibility, I can see that this is 5. So I know that 5 always comes in 5's table. Any number that ending up with 5 will always come in 5's table. Any number that ending up with 5 will always comes in 5's table. Any number that end up with 5 always comes in 5's table. Now, I will say 5 times 9 makes 45. I will cancel this one. I took 45 from this. What I am left with? 4. I'll put that 4 here. Now what it becomes? Don't say it become 9. It's 5 plus 4. No, it's 4, 5, 45. 5 times 9, 45 again. Now, whenever you get same repeated number, always go for 3 times table or 11 times table, because 11 times 1, 11, 11 times 2, 22, 11 times 3, 33, 11 times 4, 44. So whenever you get some kind of a number which is the double digit number and same numbers, repeated numbers, please try to work with 11's table. See if you get the answer in that one. So 11 times 9 makes 99. 3 times 3 makes 9, and 3 times 1 makes 3. Now here I will write this answer. These are the prime factors. Look, 2, 5, 11, 3 and 3. Can I divide 2 into any other factors? No, 2 have only 2 factors, 2 and 1. 5 only comes in 1's table and 5's table. 11 only comes in 1's table and 11's table. 3 only comes in 3's table or 1's table. This 3 only comes in 3's table and 1's table. Now here's the main point. Sometimes students say, teacher, this 11 is up and 3 is here, so this is wrong. No, it's not wrong. I can start with 11 here if it is applicable. I can start with 2 here. I can start with 5 here if it's applicable. Order doesn't matter in this case, because all these numbers will surely come. They might have different order. If I'll use 5 first, then I will get 2 somewhere else here. If I'll use 3 here, then I will get 11 something somewhere here. So that doesn't really matter which order you're working with, but please always try to start with the smallest possible number. Don't go for big huge numbers, because in that case you will make a mistake and you will not write the prime factor. So because our main concern is writing the prime factors. If you're not writing the prime factor, then the whole concept is wrong. So what I'm going to do is now I will say 2 times, okay, this is done. So let me write down the prime factors. 2 times 5 times 11 times 3 times 3. Now I'll get back to the question. Here it says that as a product of powers of its prime factors. So what I will do here, instead of writing 3 times 3, I will write 2 times 5 times 11 times 3 square. So this is my answer. I hope you understand the topic, and this is the grid division, and that is the one that we did was a tree division, tree factorization. In this one it's very simple. I will give you one quick example. If this is 36 and I'm going to write down the prime factors for this one, I will start with 2 times 18, 2 times 9. Those who get confused, they can say 2 times 18, 2 times 9. So now 2 times nothing makes 9, so I will go for 3. 3 times 3 makes 9. 3 times 1 makes 3. So now what are my prime factors? My prime factors are 2 times 2 times 3 times 3 times 3. So sorry, 3 times 3, 2 digits. So I can write this as 3 square, I can write this as 2 square. That is my answer.